Okay, everybody. Oh, is this on? Let's get started. So as you can see, there is an error in question 14 of the assignment. It's a cut and paste error because question 14 is essentially the same as question 13. So when I was making up the questions, I just copied 13 and then changed a few things, but didn't change the word first to last. So you have to, you should list the file name that comes last alphabetically. Right? If you can get the one that comes first alphabetically, that's great too. But the question is asking for the last one because it's the easier version of the question. Okay. So today's lecture is about expansions, continued. So Bash has many expansions. Last time we looked at path name, or what's actually called file name expansion if you look at the Bash documents. The next kind of expansion is something called brace expansion. It's a bit of a weird one. So you use it when you want to generate strings that follow some sort of pattern. Right, so when you're working directly on the command line, you're probably not using brace expansions very often. You are sometimes, but not very often. They're more useful in scripts, which we'll start talking about, I think, in the next lecture or two. So a brace expansion has the form pre-expression post, where expression is inside braces. Okay? Pre and post, they're just strings. Right? So pre is called the preamble. Post is called the postscript. And expression is, well, I'll show you examples of what the expression is in a second. Pre and post, they are optional. Right? So they don't have to be there. Okay, so your expression, this says it's a series of comma-separated strings, or it's a sequence expression. So what are all these things? So the preamble is this. Okay, so remember this thing here, this pre-expression post, this is going to generate strings according to some pattern. The preamble is the string that appears in front of every generated string, right? That's why it's called the preamble. The postscript, that's the string that appears at the end of every generated string, so that's why it's called the postscript, right? And the expression, well, that's the magic in the brace expansion, right? That's the part that generates all of your different strings, right? So the expression generates the part of the string that's between the preamble and the postscript. So the only interesting thing about this expansion is the expression, right? So for example, you can have an expression that's a comma-separated series of strings, right? You have to be very careful here not to put a space after a comma, because otherwise it won't interpret it as a brace expansion. Right? So no spaces after the comma, so you can do something like echo braces A, comma, B, comma, C, right? And if we try that on the command line, right, we can do echo brace A, comma, oops, don't do that, B, comma, C. Right, remember echo is just going to print the strings that are generated, the strings that it receives as arguments. So in his case, it generates, it receives 3 strings as arguments, right? A, B, and C. You can see that, right? Yeah, good. Right? Okay, good, you can see it. Right, so what the expansion does is it uses each copy of the string that's inside of the braces for one of the generated strings, right? So in this case, it generates the A, right? It generates a string with no preamble, no postscript, and A in the middle, right? Then it generates a string with no preamble, no postscript, and a B in the middle. And then finally, the string with no preamble, no postscript, and a C in the middle. If you put the spaces in, if you put the spaces in, right, the shell does not interpret it as a brace expansion, right? It just thinks it's a string, right? It's one big string. Okay, so that's a, oh, you can, hang on. Right, you don't have to have just single letters either, right? So you can do ABC, comma, XYZ, IJK, right? And you'll get those 3 strings, right? So the strings can be anything. If there are special characters in the strings, you have to do something about that, okay? But I'll show you how to deal with special characters shortly. Right? So for now, everything's just letters, numbers, and the underscore, okay? Okay, now that's great. if you want to make a few strings where you know what the middle part of each string should be, right? But where this thing really is useful is that you can generate things based off of simple sequences, right? And the sequences have a short form, right? So the short form that they take is similar to a Python range, right? You can specify the starting value, x. You can specify the ending value, y, and there's a dot dot between them, right? Now, unlike the Python range, the expansion includes the y, right? So in a Python range, you don't include the y. In an expansion, you do include the y. And if you don't want to take steps of 1, you can specify the increment, right? So you can take steps of 2 or 3 or 4 or whatever you like. Negative if you want, right? So we've got a bunch of examples here, right? So brace 0 dot dot 9. You can guess that's going to generate the 10 strings 0 through 9, right? So echo brace 0 dot dot 9. There you go, right? You've got the 10 strings all made up of a single digit. You can go backwards, and you don't need to specify the step, right? So I can go 9 down to 0, and the bash is smart enough to know you want to go backwards, right? So you don't have to specify the step size. You can specify the step size if you like. So dot dot, let's take steps of 2, right? 0, 2, 4, 6, 8, right? You don't get the last one if the step takes you past the last one, right? So you don't get the 9 in this case. What else do we do? 10, 22. Oh, you can use letters, right? I can use letters. So A through Z, right? You can do big A through little z, and that gives you all of them. Plus, it gives you a bunch of special characters as well, right? Notice it gives you the opening square, the closing square, the caret, the underscore, and the backtick, right? If you're wondering where these come from, these are all because this is encoded in ASCII, I'm pretty sure, or something like ASCII. ASCII tends to be a subset of anything else anyway, right? So big A comes before little a, and for some reason, the alphabet's not joined, right? There are intervening characters. I don't know why that's the case, but whoever invented the ASCII standard made it that way, and so that's what we're stuck with, right? You can skip characters as well, right? So dot dot 3. Skip every third word, letter, right? Now that step size has to be an integer number, right? You can't, so for example, I'm pretty sure it has to be an integer. I don't believe you can put in like a C here. Yeah, oh, there you go. That's interesting. Oh yeah, so that gets so Bash says I can't interpret that as a brace expansion, so I'm just going to give you the string instead, right? And away you go. Oh, okay, so that's your brace expansion. Now, you might ask yourself, why on earth am I going to do this, right? And so, for example, you can do something like make a whole whack of directories where the first level of directories are a year, and then the second level of the directories are a month, right? You can go further if you want. You can put in days if you like as well, right? So if you're keeping track of something, like, say, photographs, month by month, you might do something like this. Right, and we can run this, so let's try this out. So I'm going to, oh, hang on. I'm going to go back to my home directory. Control L. Do I have a temp? OK, so I'm going to make a temporary directory so I don't mess everything else up. OK, so I can do make dir minus p. And I'm going to do from 2017 to well, let's do 21. Slash, and then I want the months 0 through 11. Right, press enter, there's no error. Do ls. Oh, sorry, what did I do? Make dir, haha, sorry, my bad. Dot dot. Dot dot. It's better. ls. There we go. Right, so you can see I have the 5 directories 2017 through 2021. If I list the contents of, say, the 2017 directory, you can see I have the, did I do the wrong? No, I have the 11, the 12. Directories there. You can, when you generate the range, star. Okay, so I just nuked everything. When you generate the range, you can 0 pad stuff, right? So if I want to 0 pad everything, I can write 0, 0, right? There are the year directories. And when you go into the when you go into the, when you look at the year 2017, you can see the months 0, 0 through 11. Right? This is particularly useful because instead of counting from 1 or 0 up to 12, right, without the leading 0, right, notice what happens when you list them alphabetically. Right? You don't get them in numeric sequence. Right? You get them in alphabetic sequence. So you go 0, then 1, then 10, then 11, then 12, then 2. Right? Whereas if you're actually storing things as months, you probably want to go from month 0 to month 1 to month 2 to month 3 and so on. Right? So that leading 0 is not insignificant in some cases. Right? Cool. Okay, you can make a bunch of empty files if you want to. Right? So I can generate 30 files all in one shot. Right? Exactly why you'd want to do this, I don't know, to be honest. But let's do it. Touch, file, 0, 0 through 30. I guess this is 31 files. ls, and there they are. Right? Right? So this, so the brace expansion is useful for generating these. Oh, right. You can make the directories that are on the assignment. So if you want to try out your code, you don't make, how many do you have to make? 10 times 10, right? You'd have to make 100 directories if you did this on your own. Right? You can just type in that, and you will get the directory structure that's in the assignment. So let's try that. So I'm going to make their assignment, I think I called assignment 1, right? Something like that. And then in assignment 1, I said there's a bunch of directories 0 through 9. So make dir minus p 0, sorry, dot dot 9. Right? And then in each one of those directories, right, put in one of those, voila. ls, right? There are your 10 directories inside the assignment 1 directory. And then if I look inside any one of those directories, so I'm going to look in directory number 5, there are 10 more directories. Right? So you can generate that structure from the assignment on your own. Right? Okay, here's a modified example from the actual documentation for the bash shell. Right? So if you look at the manual, so if you go to new.org software bash, look up the manual. This gives you the definitive manual for the bash shell. Right? Anything I'm talking about you can find in the manual. There's no examples in the manual. Right? It's extremely terse, but the information you need is there. So you can nest these brace expansions. Right? And to figure out what's going on is you just start taking apart the expansions from the inside out. Right? So there's the beginning of a brace, and there's its end. Right? You've got a brace here, you've got a brace here, you've got a brace here, you've got a brace here. Right? So let me start. Oh, wait. You can't see my. Oh, you can see it. OK, good. I thought you couldn't see the mouse. Let's start taking this thing apart from the inside. Right? So I'm going to edit this slide now. I'm going to try to edit this slide. Here we go. So let me copy this line. And I'm just going to manually disassemble this expansion. Right? So I'm going to disassemble. I'm going to take apart this expansion first. Right? That's just the two strings a and how x. Right? So I can replace this with lib a, comma, lib how x. Right? So I've taken apart one expansion. Now I can take apart the other inner expansion. Right? So there's another one right here. Right? There's xedit. So that's just UCB/x and then UCB/edit. So that's easy. So let's do this. UCBx/UCB, sorry, comma, UCB/edit. Right, so I've taken apart the middle one, and now I'm just left with one expansion. Right, that one. And that has 1, 2, 3, 4 strings in it. Right? So, oh, I probably shouldn't do, well, let's do it. So there's the first one, then the second one. Sorry, then the second one, user. And then edit, right? So then there's a lib. Sorry, having a hard time with this one. lib a? Yeah, lib a. You know what? No, I'm lost, so I'm just going to run it. Let's do it that way. Sorry, it's actually hard to type on here. Oh, and now I can't paste either. Edit, paste. Is that going to work? No, of course not. Sorry. Control copy. Thank you. And there you go. So there are your 4 strings. Right? It looks like I was almost there. But anyway. Right? So you can nest these things to arbitrary depth, which makes them very hard to understand. Right? But it is doable. Okay. So that's the brace expansion. The tilde expansion we've already seen, right? So remember I told you tilde is just the short form for your home directory. It's actually an expansion, right? So it's defined as a shell expansion. So whenever you type tilde, the tilde gets expanded to your home directory unless, right? Unless that third point there, right? If tilde is followed by a username, then it expands to the home directory of the username. Expands to the path name of the home directory of the username, of the named user. Right, now on most of your systems, you're the only user, so you won't be able to try this out. I've made a user called Homer Simpson. So on this, so if I do tilde HO, right, it knows that there's a user called Homer Simpson, and I can look in his directory where you find the files dough.txt, donuts.txt, and woohoo.txt, right? Right, so that's the tilde expansion, right? It's not a particularly difficult expansion. Right, there you go. So if I type cd tilde, that changes to my home directory. Right? On your computer, it'll change to your home directory. Cd tilde followed by a username will change to the named user's home directory. Okay, parameter expansion, not useful for the time being because basically you use it with variables. Right? So whenever you have a variable name, you can substitute the variable value using a parameter expansion. So it's not super useful from the command line. The reason it's not super useful is because if you create a variable on the command line and then use it, if you close the shell, the variable disappears. Right? So only useful for temporary things. But if it's in a script, right, then it's always in the script. Right? So it's permanent in the sense that it's part of the script. Its basic form is $, brace, and closing brace, and the name of the parameter inside. Okay? And so what happens is whatever value that's stored in the variable parameter gets substituted. Right? Now, your shell has a bunch of built-in variables. Well, sorry, it has a bunch of variables that someone who has initialized your shell has created. Right? Mac is going to be very different than what you see on Linux. Right? If you use the command print env, that will print out all the variables in your environment. Right? And if you do it in Ubuntu, right, you'll see that there's a whole, well, there's quite a few. Right? Each line is another shell variable. Right? So you can see that there's a variable called shell, and that's just the name of the shell that I'm currently running. Right? My current shell is bash, so it's not surprising that the value of shell is bin bash. Right? You can see pwd, right? Remember pwd, the command, little pwd, prints out your working directory. It's actually stored in an environment variable called big pwd. Right? You can see there's my login name, there's my home directory name. Here are all the colors that ls uses. I have no idea how that's encoded, right? So if you ask me how that gives you the colors that you get, the answer is I don't know. Right? But that's how ls encodes its colors on my computer. And you can see there's a bunch of other shell variable names. Right? And you can look at any one of them by using parameter expansion. Right? So let's do pwd. Right? That holds the value of the current working directory. Right? So not surprisingly, it's home Burton temp assign 1. Right? You can get the current user's name with you can get the current user's name with user. Right? And so on and so on and so on. Okay, arithmetic expansion. So someone asked about arithmetic the other day. The answer is yes, bash can do arithmetic natively, but it can only do integer arithmetic. Right? It cannot do floating point. If you ever find yourself in a situation where you are using floating point, you have to get bash to call another program to compute the floating point answer. Right? So in other words, you need to tell bash to use a different command to compute the value of some floating point expression. However, natively, it can do integer arithmetic. Right? And if you think about it, that kind of makes sense too, right? Because most of the stuff you're doing on the command line involves file names. And it would be unusual for a file name to contain a floating point value in its name. Right? You use the double parentheses construct for arithmetic expansion. Right? Again, not particularly useful outside of a script, but because we're going to start doing scripts shortly, it's useful to tell you about them now. Right? The double parentheses construct means exactly double parentheses, right? So you put your arithmetic expression inside of a pair of round brackets, right, with a $ in front, and you can do arithmetic, right? Whatever the value gets computed gets substituted as a string after the expansion is completed, right? So if you echo $ round bracket 1 plus 1, not surprisingly you get 2, right? Boom, boom. So echo round bracket 1 plus 1. Right, you get 2. I mean, if you really wanted to, you could compute integers that you're using on the end of a variable for a file name. So here, I'm going to make the directory dir10, right? I can't think of a situation where you'd actually do it this way, right? But there's an example if you want to do it, right? The arithmetic expansions become a lot more useful when you start writing scripts. Okay, so what operators do you have if you're going to do arithmetic? Well, the answer is you have all of the usual suspects, right? Because you know Java, right? You get all of the Java operators, right? Plus plus, post increment plus plus, post increment minus minus, right? You get pre-increment plus plus and pre-decrement minus minus, right? The order that I'm listing them here is their precedence, right? So x plus plus has the highest precedence of all of the operators, right? Followed by plus plus x, and then unary minus and plus. So that's negative, that's negation, and you normally don't write plus x, right? But that's what the other operator is. That's plus, that's unary plus, right? Which doesn't do anything, but that's what it is. It's defined. Unlike Java, there is an exponentiation operator, right? So you can do star star for exponent. The only thing on this table that's different from Java is that the remainder operator, right? So it almost behaves the same. So if both your values are positive, then that behaves the same as Java's remainder operator, right? The only difference is when I think the first one is negative and the second one is, when the first value is negative, it behaves differently than Java's, right? So in this case, it actually behaves the same as the C operator, which we'll get to, I guess, in a few weeks. But if both your arguments are positive, then it behaves the exact same as the Java remainder operator. Right? You may or may not have seen the assignment, the compound assignment operators. Right? Star equals, so x star equals 5 means x equals x times 5. Right? X slash equals 5 means x equals x divided by 5, and so on and so on. Right? And notice that assignment has the lowest precedence, which makes sense. Right? If you're going to write x equals some mathematical expression, you want the assignment to happen last. Right? The logical operators, their precedence sits in here somewhere. Right? So they happen after arithmetic. Okay, command substitution. So command substitution lets you take the output of a command and replace it with the command itself. Right? So if I write $ round bracket some command inside the round bracket, right, then whatever the command sends to standard output now appears here. Right? So the command is executed in a subshell, which means it's not being run in your current shell. So your shell starts another shell, runs the command in that shell, and then the result comes back. Right? And this is used in shell scripts when you want to store the output of a command in a variable. Right? So for example, suppose I want to list the contents of a directory, right? And then I want to do something with every file in that directory. Right? So one way to do it is to list the contents of the directory and store the result in a variable. Right? And then you iterate over whatever's inside that variable to do something with each file at a time. The other time it's useful is when a command does not read standard input for input. Right? So ls does not read standard input for its input. Right? It takes in command line arguments. So if you want to feed it the result of some expression or some other command, right, you have to do command substitution here. Right? So in other words, there's no way I can pipe something into ls directly. Right? So I can't do which CP and pipe the answer into ls, right? Because ls does not accept input from standard input. Right? So what does which CP does? Well, it tells you where is the CP program on my computer. Right? Well, it turns out it's in user bin CP. Right? If I try to pipe that into ls, something weird happens. Right? That's not right. Right? ls minus l dollar which CP. Right? Now it tells me, oh, hey, there's CP and there's its long listing. Right? So that's where you would use command substitution. And you can substitute an entire pipeline. Right? So you're not just limited to substituting a single command. You can substitute any pipeline of commands. Right? So for example, if I want to remove the write permission on the first 10 files that match file star text, right? This is one way to do it. Right? So let's take this apart. ls file star.text, you know that lists all of the files that start with file and then end with text. Right? Minus d is in here in case there's a directory that starts with file and ends in text. Right? Because if there is a directory that does that, then it's going to list the contents of that directory, and that's not what I want. Right? I can pipe that to the command head, which you'll use on question 13 of the assignment. Right? Head will take the first 10 items of this output and print to that. Right? And you can change how many items appear that head will print. Right? So I can so all of that stuff in the round brackets becomes the list of the first 10 files that begin with file and end in .txt, and then I can change their permissions to take away the write permission from the user. Right. So now, do I have those files here somewhere? So there they go. So I have 30 files here. Right. ls minus al. So you can see that on all of the files named with file, right, I have write permission on those. Right? So I've got write permission on all of those files. If I want to take away the write permission on the first 10, right, I enter that command. Right? And then I check, did that actually work? So I'm just going to do, file star. And it did. Right? Write permission is now gone on the first 10 files that match the pattern that I was looking for. Right? That matched the path name expansion that I just used. Right? So here we strung together a couple of things. Right? There's a path name expansion right there. Right? And then there's a command expansion right there. Right? And there's a pipeline right there. Okay, word splitting. So word splitting, I think we've kind of talked about this already. Basically, the shell uses white space. Right? So the default definition of white space is a space, a tab, and the new line. Right? So when you press enter, that's the new line character. Right? And it uses white space to delimit fields. Right? So if you want to think of it as words on your input, right, then it separates the words using space. Right? It doesn't use one space. It will merge a sequence of spaces. Right? So if you do x space, 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 y, when it does word splitting, it just gives you x and y. Right? It doesn't give you all the spaces. So it merges multiple white spaces into a single delimiter. Now, if you think about it, parameter expansion and command substitution, they can produce white space in the output that you may not want to split, right? Where this happens, right? In particular, where this might happen is if you have files with spaces in the name, right? So if you have a file with a space in the name and you do ls, ls will print out the file with a space in the name. And then when you go to, when the shell splits everything, it's going to split the file name into two parts, right? Because you have a space in the name. And that will often break most of your scripts, right? So if your script does not take into account the fact that spaces and names will get broken, right, you're going to have a problem, right? You won't be able to process those files. And guess what program returns, or guess what software that I happen to use outputs file names with spaces in the names. When I download your assignments from OnQ, I get some huge directory with your full name in it, and there's a space between everything. So when I go to process this in Linux, it becomes a real pain in the butt, right? It's worse because there's a bunch of special characters that are used in your names too, right? So the single quote is particularly irksome. Okay, so to deal with all this, you have to quote. You have to quote stuff, right? Quoting is used to remove the special meaning of certain characters or words to the shell and to prevent expansions, right? So sometimes you don't want to expand something, right? The shell has these things called meta characters, okay? That must be quoted or escaped if you want to use these for some reason, right? So if you want what's called a meta character somewhere in your file name for whatever reason, you have to escape it so that you can actually use that character, because it means something special to the shell. Right? So what's a meta character? Well, it's just a character that when you haven't quoted or escaped it, separates words. Right? So what separates words? Right? Well, I told you spaces, tabs, and new lines separate words. Right? But if you think about all the stuff we've been doing, you'll realize that there's other separators as well. Right? You know that the expansions use the round brackets. Right? So you can guess that the round brackets are probably word separators. You know those are the redirection operators. So you can probably guess that those separate things as well. Right? Turns out that or, and the semicolon also separate stuff in your shell. Right? So that's the complete list of the shell meta characters. If you want to use these in a file name, right, you have to escape them. Right? Windows, when you make a copy of a file, calls it blah round bracket 1, blah round bracket 2, blah round bracket 3. Right? Try to pull it into Linux, and Linux barfs because it thinks the round bracket is a separator. Right? Okay, unquoted or unescaped white space separates arguments. Right? That's exactly what I said. So if I try to make a file name, right, called file name with spaces.txt, right, this doesn't work. Right? Instead, what you get is 3 files. Right? I'm just going to make another directory and then go into that directory. Right, nothing here. So if I touch, what do I call it? File name with spaces. File name with spaces.txt, right? You don't get 1 file, you get 3. Right? You get the file name, you get the file spaces.txt, and you get the file with. Right? And that's because the shell is using the spaces to separate the characters. Right? Solution number 1, right? Because I have a space here, I can escape the space with a backslash. Right? And I can escape the second space with a backslash. So that's the short way to do it, to actually create a file name space with spaces. Right? And there you go. Right? When you use ls to print it out, ls will quote it in single quotes. Right? But the single quotes are not actually part of its name. Right? So those single quotes, not part of the name. You'll see why in just a second. Okay. So that backslash is called a non-quoted backslash. Right? So if the backslash is not in quotes, that's the bash escape character. And I'm just going to check this live stream. Backslash is not. Yep, that's me. It preserves the literal value of the next character that follows, right? So slash space means give me a space, right? With the exception of the new line, right? That's why when you write backslash and then press enter, you're allowed to go to the next line and continue with your command, right? And if new line appears, blah, 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 right? That's fine. Okay. enclosing characters in a single quote, right? So if you use single quotes to enclose something, right? So the Java, for a Java car, right? Then that preserves everything inside the single quotes, right? In other words, the shell does nothing to modify them, right? It won't do any expansions. It won't do any. It won't do any. It won't do any escaping or anything like that, right? So no substitutions occur if you put things in single quotes. Now the problem is, if you want to include the single quote in whatever you're using, that becomes problematic, right? So if I want the word "it's" with a single quote, that becomes a little harder to do, right? But the moral of the story is try not to use single quotes in your file names if you can help it. Right, so single quotes are easy. Just put it in, if you don't want anything to happen to what to your string, put it in single quotes, right? You'll be fine. Double quotes. Double quotes preserves the literal value of everything inside the quotes except, right, the $, the backtick, and the backslash, right? If your shell is configured to use history expansion, then the exclamation mark is also still considered a special character. Right, so $, remember $'s used to start a command substitution and parameter substitution, right? So if that's there, it retains its special meaning, right? So in other words, you can still choose to do some expansions inside a double quoted string, right? Now backslash only retains its special meaning, right? So it retains its special meaning only for a limited number of characters. Right? In other words, you can only escape a limited number of characters with the backslash inside double quotes. Right? You can escape the $, the backtick, the single quote, the double quote, the backslash itself, and new line. Right? So if you enclose something in double quotes and you want to use, retains the backslash, yes, and you want to use a $, inside the double quotes, backslash $, will give you the $. Okay, so $, keeps its special meaning inside of double quotes, right? That means word splitting, path name expansion, tilde expansion, brace expansion are suppressed, right? So none of those things will happen, right? Parameter expansion, though, remember that starts with a $. Arithmetic expansion starts with a $. Commands expansion starts with a $. They still occur, right? So here I'm doing 3 arithmetic, what looks like to be 3 arithmetic expansions, right? The first one definitely works, right? So, because there's no quoting involved, right? So if I do echo, right? So if I do echo, these small keyboards are really hard to type on. Okay, so 1 plus 1, right? I get 2. That works. Now, single quotes. What do single quotes do? They suppress everything, right? So if I put that in single quotes, right, no expansion will happen, and I will just get the string $, round bracket, 1 plus 1, right? Even though $, is significant to the shell, even though the round brackets are significant to the shell, even though the spaces are significant to the shell, right? Because the single quotes suppresses everything. Double quotes will not suppress the arithmetic expansion. So that still works. Right. Here's another example. So here I want to include the double quotes as part of the string. Right. In other words, I really want the string $hello. Not dollar, double quote, hello, double quote. Right. So I really want them quoted. So one way to do that is to enclose everything in single quotes, because single quotes suppresses everything. Right, echo, single quote, double, hello. Right, single quote says, leave everything inside the single quotes unchanged, so there you go. Right, now, if you want to use the double quotes, right, so start with double quotes, and then use backslash, double quote, right? So the backslash will escape the meaning of the second double quote, right? I need to escape the meaning of the third double quote, and then I can close everything with an actual double quote, and that works as well. right? So that's what the escape character is used for. This is very confusing. You have to do it to get used to it, right? When you look at bash scripts, there will be single quotes and double quotes flying around all over the place. I didn't tell you about the backtick, right? The backtick is the old way of doing command substitution, right? But when you look in older scripts, you'll see backtick, single quotes, and double quotes all over the place. And you need to remember what they mean in order to correctly interpret the meaning of the script. Command substitution still occurs inside double quotes as well, right? Sometimes you need the double quotes to preserve the output of the command, right? So, okay, the first one's not that interesting, right? I told you that if you have echo, this has some spaces, right? When you white split that, it just merges all the spaces and you get 4 strings, right? So you get this has some and spaces, right? Double quotes will suppress the space breaking, right? So if you want to keep the spaces, you can just enclose in double quotes. You can enclose in single quotes. Now, what happens when I do cal? Okay, so cal outputs the calendar for the current month, right? What happens if I echo cal? Echo $cal. Sorry, echo there, right? So what happens when you echo the result of so I'm going to do a command substitution, right? Command substitution, so cal runs in a subshell, right? The output appears, right? So in the subshell, the output is that, right? But when bash takes the result and breaks the spaces, right? All of the new lines, they count as white space, right? All of that space here, that gets merged as a single white space character, right? So that's why it appears as September 2021, then Sunday, Monday, Tuesday, Wednesday, right? That's why it all gets printed out in one line, right? Because white space breaking occurs, right? New lines are treated the same as regular spaces, and you end up with all in a single line. If you want to preserve the spacing, right? Double quotes will do it for you, right? Because double quotes suppresses the white space breaking. Now it works, right? Single quotes won't work, right? Why won't single quotes work? Because single quotes suppresses everything. So you won't even get the cal command. You'll just get the string $ round bracket cal, right? And that's why you need single quotes, double quotes, and no quotes sometimes, and the backslash operator, right? Okay, now you need to know the order of which of these expansions occur, right? Because you can have a large command that's got many expansions in it. That's the order that they happen in, okay? So when you're writing your scripts, if you do happen to write your script in a way where there's multiple expansions happening on the same line, you need to keep in mind the expansions happen a certain way, right? In a certain order, sorry, in a certain order. All right. I'm going to stop here because we're basically at quarter after. There's only a few slides from here anyway, so that's fine. So starting Wednesday, we're actually going to start writing some scripts, right? I can.